Hi, I'm Charanya. I'm studying post-masters in data science in the University of Eindhoven in the Netherlands, and I participate in this year's Google Summer of Code in the free parking visualization tool project. So the goal of the project is to detect free and occupied parking spaces in the parking lots and inform users, the parking admins about it, so that we get an idea of the occupancy of the parking lot using object detection models, and also view the same in the Liquid Galaxy, since this is the organization that I'm doing my project with. So the main key learnings that I have gained during this period is professionally. I first learned how to use Git effectively because I hadn't done that before, because I'm not from a computer science background. And apart from that, I also gained familiarity with a lot of technologies like object detection models, YOLO to be precise, and also the React and React Native frameworks, how to work with APIs and how to work with Docker containers. And it has been a really steep learning curve as far as technical stuff is concerned. And also personally, the project also taught me a lot, because I learned how to effectively plan and implement the plan over the past 3 months, and document my work thoroughly, so that people can understand it easily and also it can be handed over to someone. And then I also learned how to work under a lot of pressure, because the last few weeks have been pretty stressful. In the beginning, I really did not think I'd be able to finish everything on time, but I really learned this a lot thanks to the help of my mentors. So the entire project has been applied using data from CCTV cameras, 4 security cameras in Lleida's scientific park in Spain, and we have used those footages to test the object detection model, identify the free and occupied parking spaces, and visualize the same on the Liquid Galaxy as well as web and mobile applications. The data architecture of the projects consists of multiple phases in the server and client side. So the first one was the collection of data, the footages from CCTV cameras, and then annotating different parking lots in both the cameras as well as on the Google Earth for generating KML files. Then after that, processing and analysis of the data, that is running the model and testing the YOLO v4 model on the data and detecting cars, and then classifying the parking spaces as empty and occupied. And then also this entire setup has to go into a backend, of course, and there's the server built with a Flask web server built with the connection module having the Swagger YML format, and all of it is wrapped into a Docker container. I will go into detail into each one of these components in the next few minutes. Then these backend also gives rise to the 3 apps which acts as the backend and then display all the information that is required. 2 apps, that's the web app and the mobile app, and of course visualization in the Liquid Galaxy. So now let's go into detail into each of these components. The YOLO v4 model, also called You Only Look Once, is a state-of-the-art object detection model that's used in deep learning, and it is built using convolutional neural networks, and it has been tested with a lot of different features, classifiers and detectors, and a lot of hyperparameters. And it has an outstanding accuracy and a really good detection speed. This is the structure of the neural network, and these are the YOLO V4 model uses the CSP darknet model as a feature extractor model, and the accuracy achieved is about 43.5% for real-time object detection, and the speed is about 65 PS on a V100 GPU. The way that this is done is by using the COCO data set, which is the Common Objects in Context, which is used for large-scale object detection segmentation. So there's a set of 80 predefined um, class names, which include cars and trucks, which we have imported. And I have also included the YOLO V4 weights, which are pre-trained in order to develop this model and then test it on the data that we have. After this is done, we classify the occupancy based on the bounding box of the detected object. So this entails that when the YOLO V4 model detects a car in a particular location, we calculate the center and see if the center lies within the predefined bounding box of the parking lot. And if it does, then we classify the parking space as occupied. And the rest of the parking spaces are free because we already have annotations for that. So to go into, now that we have the model, the backend is built using the Flask web server, and the Flask web server connects to a REST API endpoint using the connection module, which can be installed using pip, and it allows a Python program to use the Swagger specification, which you can see on the screen. It provides a lot of functionality such as input-output validation for data to and fro from your API, and an easy way to configure the API URL endpoints and the parameters, and also a really nice UI interface to work with. So the swagger.yml is a YAML or JSON file which contains all of the information necessary to configure the server and to provide input parameter validation and output response validation. So you can see the Swagger YAML file here, and there are multiple routes which you can see, such as camera 1, camera 2, and the rest. And the server can be accessed to these specific routes to get the required information. The backend is wrapped up into Docker containers. Docker is a micro server which contains all the code required, and it automatically runs, and it has Ubuntu 18.04 installed in it. So essentially the project contains two Docker containers, one for generating the RTSP server for the media stream for the CCTV camera footage, because we still do not have access to the IP cameras. This contains three files: the RTSP media server, video.py, which generates images and saves them into the folder, and we pass the video footage downloaded from the security cameras. The second Docker container contains the script for the main model and the server, and also the parts of the communication with the Liquid Galaxy. To start the first Docker container, we just have to pull the ones as mentioned on the screen and then run the Docker container. So then that will run
the RTSP media stream and save images inside the API folder. SetRegions.py it can also be used to set annotate the bounding boxes of parking lots in the camera footage, which is downloaded from the CCTV camera. And the API folder contains all the files of the server and also the .NET model, which the .NET.py is the main file here, which runs the model. And all the other files are stored in templates, the images for the model, as well as the new files which are generated, KMLs or text, which are used to communicate to the Liquid Galaxy. The way to start the second Docker container is to simply run the command that you see in the screen, and with a single command it builds and installs all the required dependencies such as Ubuntu, all the pip modules from Python 3, and the server runs, and then you just pass the docker run command, and yeah, then that implies that the server is running. You can also view the logs by writing sudo docker logs, the container name. And
apart from the visualization on the Liquid Galaxy, the two deliverables of the project were one, a web application for the parking administrator to view the occupied and the free parking spots and continuously monitor the presence of cars in 4 parking lots in different regions of the scientific park. And a second one is a mobile application which enables the users who are using the parking lots to actually view
the occupancy of the parking lots. So let's first go to the web application. Yeah, the web application displays all the key information statistics, as you can see, for each parking lot, and also you can view the camera output of magical parking lot, for instance, and also the main parking lot. And it also contains 2 more buttons. In order to view the files on the Liquid Galaxy, the KML files, you have Orbit Parking 1 and Orbit Parking 2. So when I click on Orbit Parking 1, we can see the demo on the Liquid Galaxy. The Liquid Galaxy is flying to the main parking lot, as you can see. Here, the yellow boxes indicate the ones out of camera view because we have only 2 cameras. The green boxes represent the free parking spaces. The red ones represent the occupied parking spaces, and the blue boxes represent the reserved parking spaces. It's much clearer when it's close by. Now on clicking Orbit 2, we go to the second parking lot, which is the magical parking lot, and the same visualization can be seen here. And the, the information about the statistics of each parking lot are seen on the rightmost slave machine screen. Now let me quickly tell about the mobile app.
the mobile app is built using React Native framework, and it helps the users to view which parking lots are free beforehand. So let's check the app. First, when you open it, the user can sign up by entering a few details. I'm also trying to include the Google sign-in option, which I will do after the making of the video. So then after once they sign up, they can sign in, and the screen loads to the server IP where whichever server the backend is hosted in has to be input here. And once they input the home page loads, and the user can see various details such as the percentage occupancy, and also when you click on the view parking spaces button, then you can see the occupancy images of all the parking spaces. We've taken 4 parking spaces in this case, so when you click on each button you can see all the 4 parking spaces, and also it displays the key statistics of the occupancy of the parking lots. Then there's also an about page where the source code is linked, and the user can view all of the details of the project here.
The app has an APK version has been generated, and it is available on the Google Drive and on the documentation as well for downloading.
The future work will be to firstly link the IP of the cameras, the security cameras, directly to the application, because right now we are generating it like I explained earlier using the media stream. So if that is done, then it will have a completely circular project. Then the second thing that can be done is to add more functionalities to the app to increase the overall user experience, such as the Google sign-in. And yeah, so that's pretty much it. And before I finish, I would like to heartily thank my mentor, Moises Martinez, and of course Andreu, who was all there supportive the entire time. Both of them for their continuous patience and guidance, and also all the other mentors that I had for the project, Mark, and the students of the Liquid Galaxy lab who helped me in handling a lot of things when I was stressed out, and also annotating a lot of the parking spaces, Claudia, Gabri, and all other students whose names I don't know. And last but not the least, I would really like to thank Google for giving me this opportunity, and the Liquid Galaxy lab as well for trusting me with this project. I definitely had a lot of fun learning new things and implementing all the things planned for the project, and I hope that it's carried forward and all the future work is done sometime. Thank you.